Hello guys, welcome. Today we are going to talk about velocity and acceleration. In the past video, I talked about distance and we're also going to incorporate that inside of this video. Yeah. So let's assume that the car is moving from point A, this point, to point B. And we assume it's moving in the right direction. Now, when we move in the right direction, in physics, we always treat this as going in the positive direction. See, the car moving from point A to point B, we could say the car is moving in a positive direction. Now, because the car is moving in a very uniform distance, as you can see here, 0 second, it covers 0 second here. Then after 1 second, it covers 20 meter. After 2 seconds, it covers another 20 meter. After 3 seconds, it covers another 20 meter. We can assume that the car is moving in a uniform velocity because it's moving with the exact same time that covers the same distance. As you can see, the car is moving in a uniform velocity because its rate of change of displacement remains the same, meaning its rate of change of displacement over dt equals to 0. The rate of change of its displacement, displacement, this is not a circle, this is 0. It's always 0. That's why it's moving in a uniform velocity. And you can see down here another example. This is time 0. After 1 second, it moves 20 meter. After 2 seconds, it moves 30 meter. So it has a different distance after the difference of 1 second. So we can see that the car is moving in a non-uniform velocity because its rate of change of displacement is increasing. As you can see, after 1 second, 1 second has passed by between this position and this position. The rate increased from 20 meter here. It increased, I would say, increase in 10 meter, making it into 30 meter. It increased in 10 meter. So you can see that this car, this blue car, is moving in a non-uniform velocity, and the red car, which has 0 changes in its displacement, even though it has gone through 3 seconds, we could say it's moving in a uniform velocity, and the blue car is moving in a non-uniform velocity. Now, speedometer is a device that we use to calculate the speed of the car, and if the speedometer has a constant reading, meaning it has a uniform velocity, and if it has a varies, meaning it's non-constant reading, meaning we have a non-uniform velocity, and non-uniform velocity will result in acceleration if the velocity increase, or deceleration if the velocity decrease. Let me just type deceleration if the velocity decrease, and acceleration if the velocity increase. Now, speed is equal to the rate of change of distance traveled. The rate of change, meaning time, and distance, meaning the length traveled. So we could say rate of change of distance traveled is distance traveled over time taken, and can be resolved into this equation: V is equals to d over t, d as in distance traveled and t as in time taken to get from one point to the other. For example, we have A, B. Alright, so this is, let's assume 50 meter, and the time taken to get from point A to point B is 2 seconds. We could calculate the speed by putting in the distance, 50 meter, over the time over the time, 2 seconds, and we would have 50 divided by 2, 25 meter per second. That would be the time. Sorry, that would be the speed. That is the one of the examples that we can use if we want to calculate speed. And I will remind you that we can only calculate the speed if we have a constant velocity. If we have a non-uniform velocity, that means we can't calculate the speed just like that, because it has a non-uniform velocity. It involves acceleration, and we're going to look towards acceleration right after this. Now the velocity, as I mentioned earlier, that was speed. This one is the velocity, is the rate of change of displacement over time taken. Now the speed only involves in magnitude, while the velocity involves in displacement that has magnitude and direction. Direction. We would have the same formula as speed. However, velocity is displacement over time. The time is it will be the same as in speed, but the velocity, the difference is that we use displacement instead of distance. So if you want to calculate from point A to point B, for example, if I move from point A to point B 50 meter in 2 seconds, the velocity would be 25 meter per second. But however, if I move back from point A to point B to point A, my velocity would be 0, because my displacement is equals to 0. So that's the main difference between velocity and speed. And next is the acceleration, which is the rate of change of velocity. The rate of change of velocity, the rate of change meaning time, change of velocity means the final velocity minus the initial velocity. So you can get this equation. And lastly, you can get this equation, which is, let me just put it here, which is acceleration is equals to final velocity minus initial velocity over time. So how can we use this in our how can they ask this in questions? For example, I have point A to point B. Alright, at point A, my velocity is 0 because I haven't started the car yet, and right now I'm riding a car. And when I get to point B, my velocity is 50 meter per second, and the distance from point A to point B is 2 seconds. So I would say that my acceleration would be my final velocity, 50 meter per second, minus my initial velocity, which is 0 because I haven't started the car yet, over the time taken to get from point A to point B, which is 2 seconds, or the time taken to get from velocity, the final velocity, to the initial velocity, 2 seconds. This is second, not 25. So we would get 25 ms squared. This is acceleration. So yeah, that's basically it. We would get this answer. Acceleration is equals to 25 per second square. And yeah, that's basically it. If you want to see more videos, go ahead, please like and subscribe, and let me know if you have any question in the comment below. Thank you very much.